So 8th class of EE311, 8th class, improving the armature reaction effect. We studied what is meant by armature reaction. We studied the effects of armature reaction. Armature reaction means it is the effect of armature flux on main flux. It is the effect of armature flux on main flux. It should be avoided because it has two adverse effects. One is demagnetizing effect and the other is cross magnetizing effect. Due to this demagnetizing effect, resultant flux in the machine decreases, generated EMF decreases. Due to cross magnetizing effect, sparking takes place at the brushes which may destroy the machine. Anyway, these two effects should be minimized at any cost. So how can we improve the effects of armature reaction? So we can adopt four different methods. We can adopt four different methods for improving this armature reaction effect. So we can discuss all those things one by one. First one, using interpoles or compoles. Using interpoles or commutating poles or compoles, we can minimize the effect of armature reaction to a certain extent. We can minimize the effect of armature reaction to a certain extent by using interpoles or compoles. Compoles means commutating poles. What is it? To counter the effect of armature reaction, place a set of interpoles midway between the main poles of a DC machine as in figure A. Look at the figure A. Look at the figure A. There are small poles fixed between the main poles. So larger poles are main poles. There are small poles fixed between the main poles. The polarity of main pole is just same as that of the main pole as in the direction of rotation. So look at the figure. The interpoles or compoles are fixed between the main poles. The polarity of this interpole is same as that of the main pole ahead as in the direction of rotation. Okay, the polarity of interpole is same as that of the main pole ahead. Main pole ahead in the direction of rotation. In the case of a DC generator, in the case of DC motor, this effect is not so, just opposite. The polarity of interpole is same as that of the main pole behind as in the direction of rotation. Anyway, leave it. Now we are discussing about generator armature reaction effect. So polarity of interpole or commutating pole is same as that of the main pole ahead in the direction of rotation. So these are the small poles, interpoles or commutating poles or compoles. Commutating poles are also known as compoles. Compoles means commutating poles fixed between the main poles. The polarity of these main poles is same as that of the main pole ahead in the direction of rotation. So these are for improving the armature reaction effect. So how can we minimize this armature reaction effect by using these small poles fixed between the main poles that we are discussing now? Interpoles set up a flux equal and opposite to the armature flux. We know that because of the armature flux this problem is created. Armature reaction is created only due to the effect of armature flux. So we can reduce the effect of armature flux. These interpoles can set up a flux which is equal and opposite to the armature flux. How? Interpole windings are connected in series with the armature so that respective fluxes rise and fall together as the load current changes and cancels the armature reaction effect. What is the meaning of this sentence? That means interpoles are small poles. These interpole windings are connected in series with the armature. Interpole windings are connected in series with the armature. The polarity of interpole is same as that of the main pole ahead. Okay, so interpole windings are connected in series with the armature. Therefore, the same armature current is flowing through this field winding also. Same armature current is flowing through this field winding also. Interpole windings are connected in series with armature. Therefore, same armature current is flowing through the interpole windings also. When load increases, armature current increases, current through the interpole winding also increases. When load decreases, armature current decreases, current through the interpole winding also decreases. Because all our interpole and armature are in series. Interpole windings are connected in series with armature so that respective fluxes rise and fall together as the load current changes and cancels the armature reaction effect. That means when load increases, load current increases. Load current increases, armature current increases. At the same time, current flow through the interpole field winding also increases. Okay, so this interpole current, the current flowing through the interpole winding can create a flux. This armature current can also create a flux. So same current is flowing through the armature and interpole winding. So the magnitude of armature flux is same as that of the flux produced by the interpole, but its direction is just opposite. And therefore this flux produced by interpole winding can minimize this armature flux. So flux produced by armature winding is just opposite direction to that of the flux produced by interpole winding. The magnitude of flux are same, directions are just opposite. The interpoles and main poles are placed in such a way that flux produced by interpole winding is just opposite to the flux produced by armature winding in direction wise. Therefore magnitude is same, directions are opposite. So flux produced by armature is cancelled by flux produced by the interpole winding. Thus we can reduce the effect of armature flux, and hence we can minimize the effect of armature reaction, because armature reaction is the effect of armature flux or main flux. To minimize the effect of armature reaction, we have to minimize the armature flux. For that we are providing some interpoles or small poles fixed between the main poles. We are providing a winding on the interpoles. The interpoles are connected in series with armature. So same magnitude current is going through the interpole and armature. So the machine is designed in such a way that the direction of flux produced by interpole is opposite to the direction of flux produced by armature. Therefore magnitude is same, direction is opposite. The cancel of armature flux takes place. Therefore the effect of armature reaction is reduced to a certain extent. Okay, so that is the first method. By using interpoles or commutating poles, we can reduce the effect of armature reaction. But so look at the last sentence. Interpoles are fitted to all machines except those of the smallest size or lowest speeds. So these interpoles are applicable only for low speed machines or small size machines. For larger machines, this method is not possible. For larger machines, by using interpoles or compoles, we cannot minimize the effect of armature reaction. For small sized machines or low speed machines, this method is necessary. I am repeating, interpoles are small poles fixed between the main poles. Interpole winding is connected in series with armature. Same current is flowing through the armature. Same armature current is flowing through the interpole winding. But the machine is designed in such a way that the flux produced by interpole is opposite to flux produced by the armature. So magnitude is same, direction is opposite. Therefore the two fluxes are cancelling each other. So only main flux is there. No interpole flux, no armature flux. Even though interpole flux and armature flux is there, both of them have equal in magnitude and opposite in direction. They are cancelling each other. Only phi1 is there. So this method is applicable only for low speed and low sized machine. Okay. Then second method, using compensating winding. To eliminate the problem of this armature reaction, what we have to do? The second method is compensating winding. An additional compensating winding are used in the case of a DC generator. A compensating winding is an auxiliary winding embedded in the slots in the pole face of the main poles. Compensating winding is connected in series with armature in a manner so that direction of current through the compensating conductors in one pole face will be opposite to the direction of current through the adjacent armature conductors as shown in figure B. So look at the figure B. Look at figure B. The second method for improving the armature reaction effect, compensating winding. So two main poles N and S, north and south, are shown in this figure. In the wider part of the pole is known as pole shoe. In the constructional details we studied, the wider section of the pole is known as pole shoe. In the pole shoes of a compensating winding is provided in the pole shoes of a DC generator. Okay. The direction of current through the compensating winding is opposite to the direction of current through the armature conductors in the influence of that particular pole. For example, under the influence of north pole, compensating winding is provided. Under the influence of this north pole, some armature conductors are there. Current flow through these armature conductors is opposite to current flow through this compensating winding, which is provided in the pole shoe of north. Okay, so compensating winding is also connected in series with armature. So same current is flowing through the armature, but direction of current flow is just opposite. So compensating winding produces a flux. Armature conductors can produce a flux. Both of them are equal in magnitude. Why? What is the reason? Compensating winding are connected in series with armature. So same current is flowing. So they can produce same flux. So magnitude is same, but directions are opposite. So they are cancelling each other. So only main flux is there. In the same manner, in the south pole, the pole shoe of south pole, we can see a compensating winding. Under the influence of the south pole, some other armature conductors are there. So direction of current flow through the armature conductors which lie under the influence of the south pole is opposite to direction of current flow through the compensating winding of south pole. So same current is flowing through the armature conductors and compensating winding, but directions are different. Therefore, flux produced by compensating winding and flux produced by armature have equal in magnitude and opposite in direction. They are cancelling each other. So the resultant flux remains constant. That means flux produced by main winding. That means main flux is there. Even though armature flux is there, at the same time the same amount of flux in opposite direction can be produced by compensating winding. They are cancelling each other. So there is no effect of armature flux. So only main flux is there. So by using this arrangement, we can reduce the effect of armature reaction to a certain extent, but the main disadvantage of this method is it is very costly method. It is a very costly method. Okay, so compensating winding is applicable only for compensating winding produces look at the last. The addition of a compensating winding considerably increase the cost of the machine and is justified only for machines intended for unusually severe service, because of high cost. This is not applicable for normal service. Okay, so that is the main disadvantage of this method. Cost is more. What about the disadvantage of first method? So both methods are okay. The first method is by using interpoles or commutating poles, we can reduce the effect of armature reaction to a certain extent, but we can provide interpoles or compounds to those machines who have low speed or low size. So that method is applicable only for low speed and low size machines. And second method is compensating winding. Compensating windings are provided on the pole shoes of the main poles. The direction of current flow through the compensating winding is opposite to the direction of current through the armature conductors which are lying under the influence of the same pole. Okay, so same current is flowing through the armature conductors and compensating winding, but the direction of current flow through the compensating winding is just opposite to the direction of armature conductors which lie under the influence of the same pole. Therefore, both fluxes are cancelling each other. Both of them have equal in magnitude, opposite direction. Therefore, they are cancelling each other. But that method is applicable for unusually severe service. That means because of high cost, this is not applicable for ordinary service. That is an ordinary service. That is the main disadvantage of the second method. Okay, what about third method? For improving the armature reaction, we can use several methods. For low size and low speed machine, we can use interpoles. For high speed machines or high sized machines, we can use this compensating winding. There is a problem. The compensating winding is a very costly method. And what about third method? Modify the ends of the field pole shoe so that high flux cannot exist on the ends because of the high reluctance path. I told you that because of armature reaction, unequal flux distribution takes place. In the trailing pole tip, flux density will be more. In the leading pole tip, flux density will be less. In the trailing pole tip, flux density will be more. In the leading pole tip, flux density will be less. So this is the effect of armature reaction. Increase in flux density at pole tip B is less than decrease in flux density at A. That means resultant flux decreases. This effect is known as demagnetizing effect. We discussed all those things in the last class. So by modify the shape of the ends of the poles in such a way that we can reduce this effect. We can reduce this unequal flux distribution by providing more reluctance, by providing more reluctant material. By providing high reluctance path, we can avoid this unequal flux distribution and we can avoid this effect to a certain extent. Because of this unequal flux distribution, demagnetizing effect and cross-magnetizing effect takes place. By using high reluctance path magnetic material or by modifying the end of the pole shoes, we can avoid this unequal flux distribution. That is the third method. Modify the ends of the pole shoe so that high flux cannot exist on the ends because of high reluctance path. So we can avoid the unequal flux distribution at the trailing pole tip and leading pole tip by providing higher reluctant materials. That is the third method. Okay, by using that method we can avoid that. Because of this unequal flux distribution, there are two effects are there, demagnetizing and cross-magnetizing. By avoiding this unequal flux distribution, we can avoid the two different effects, demagnetizing and cross-magnetizing. That is the third method. And what about the last method? Because of the cross-magnetizing effect, sparking takes place at the brushes. So please look at the slide. To ensure good commutation, brushes must be placed in neutral zone. Neutral zone means magnetically neutral axis is there. MN is the axis along which no EMF is. North pole is one side and south pole is in the opposite side. In the neutral, there will be an axis on the neutral zone. When the armature conductors lie on this axis, no EMF is induced in that axis. MN is the axis along which no EMF is induced in the armature conductors. There is a neutral zone, means magnetically neutral plane is there between north pole and south pole. There is an MNA between a north pole and south pole. When the armature conductors are on those magnetically neutral axis or neutral zone, no EMF is induced in the armature conductors, no armature current is there, no armature flux, and thus we can avoid the effect of armature reaction to a certain extent. That is the fourth method, and thus we can avoid the cross magnetizing effect and sparking to a certain extent. Okay, to ensure good commutation means by avoiding the sparking of brushes, by avoiding the cross magnetizing effect or sparking of brushes, what we have to do, brushes must be placed in the neutral zone. Neutral zone means magnetically neutral. It is neither north nor south. Between a north pole and south pole, there is a magnetically neutral plane is there. That axis is known as MNA, magnetic neutral axis. When the armature conductors lie on this MNA, no EMF is induced in the armature conductors. Okay. To ensure good commutation, brushes must be placed in neutral zone. However, due to distortion of flux, neutral zone is shifted. By using the brush hanger mechanism to find the correct neutral position, rotate the brush hanger in such a way that brushes should be placed in neutral zone. But there is a disadvantage there is a defect for this method. Such a method can be applied only for a fixed load current. These are not applicable for varying load application. When load changes, load current changes, neutral zone also changes. So it is not possible to shift the brushes always according to the variation of load current. For fixed load application, when load is fixed, load current is fixed, so magnetically neutral axis is fixed. So by using the brush rocker or brush hanger mechanism of the machine, we can place the brushes at neutral zone. So we can avoid the cross magnetizing effect and sparking to a certain extent. But varying load application, when load changes, load current changes, the magnetically neutral axis zone is also changes. So magnetic neutral zone is always changing according to the load variation. Therefore, this method is applicable for fixed load machines. Okay, this is the last method for improving the effect of armature reaction. Last method is for improving the effect of armature reaction. Place the brush axis in the magnetically neutral zone. Magnetic neutral zone is always changing according to the load. When load is fixed, magnetic neutral zone is fixed. For varying load applications, positioning of a magnetic neutral zone is not easy. So place the brushes in the magnetic neutral zone by arranging the brush rocker or brush hanger mechanism. There is a brush rocker or brush hanger mechanism for each and every generator. By adjusting that brush rocker or brush hanger mechanism, we can place the brushes at the neutral zone. If we are providing the brushes at the neutral zone, okay, we can avoid the cross magnetizing effect and brushes to a certain extent. But this method is applicable for fixed load applications. When load is fixed, load current is fixed, magnetic neutral zone is fixed. But when load is varying, load current is varying, magnetic neutral axis is varying. Therefore, positioning of magnetic neutral zone is not easy with the help of brush rocker or brush hanger mechanism, which is fixed on the end cover of the machine. Okay, by using that mechanism, by using that brush rocker or brush hanger mechanism, we can fix the brush position in neutral zone. That neutral zone depends on load variation. If load is fixed, that zone is fixed. If load is not fixed, that zone is not fixed. So it is applicable only for fixed load machines. These are the 4 different methods for improving the effect of armature reaction. I am repeating. First one, interpoles or compoles. Interpoles are small poles fixed between the main poles. The direction of interpole is same as that of the main pole ahead in the direction of rotation in the case of generator. So interpole winding is connected in series with armature. Same current is flowing through the interpole. The interpoles are designed in such a way that flux produced by interpole is opposite to flux produced by armature current. Same magnitude current is flowing through both. So the fluxes are cancelling each other. Armature flux and flux producing interpole windings are cancelling each other. Thus we can avoid the effect of armature reaction to a certain extent. But this is applicable for low speed and low size machines. Figure B, the second method is compensating winding. By providing compensating winding on the magnetic pole shoes, we can decrease the effect of armature reaction to a certain extent. Interpole winding is connected in series with the armature. Direction of interpole winding is opposite to direction of armature current. Therefore, armature flux is cancelled by the compensating winding flux. Thus, we can reduce the effect of armature reaction to a certain extent. But this method is very costly. And third method is by shaping the brushes in such a way that we can avoid the unequal flux distribution, and thus we can reduce the effect of armature reaction. And the fourth method is by positioning the brushes in the magnetic neutral zone, we can avoid the sparking of brushes, and thus we can ensure good commutation or sparkless commutation. Good commutation or sparkless commutation. These are the different improving methods to reduce the effect of armature reaction. I think it is clear.